Yo, what is up, Bitcoin miners? Happy Thursday for us. I don't know what day it is for you guys. Doesn't really matter. Don't care. Um, Welcome to the Build a Mine podcast. I'm your host, Trevor. And as always, we like to, on this show, we like to dive into hash rate heating projects. We dive into, different types of software, firmware. We dive into builds. We do a lot of different things, but everything is related to Bitcoin mining. And I'm really excited for today's episode because we have our first repeat guest. Now, some of you might remember, but we had Nico D on a couple of months ago. I think it was back in October, September time, somewhere around there. We had him on and we talked a lot about his immersion system that he integrated into his home heat, hydronic boiler, water heater, all that good stuff. So what we're going to be doing today is I actually have an immersion tank coming. It's going to be here tomorrow. I have the M1 fog hashing immersion tank coming. And what I'm going to be doing is I'm going to be integrating that into my hot water system. Hold on, let me turn off my notifications because I forgot to do that. All right, no distractions. Anyways, so we're going to be talking about my immersion system. We're kind of going to be just walking through it, trying to decide how I should maybe go about doing this build. Nico is amazing with the way that he's done things. Everything he's done has been learned. Like if you watch the previous episode, which I highly recommend, I'll actually link it in the description of the video. But I highly recommend that you go back and watch that because the way that we ran through the system, it makes a lot of sense on how you could actually build your own. So we're going to take him and his knowledge, the stuff that he's learned over the past, year and a half of just kind of DIYing it. And we're going to try to overlay that onto my project so that I can get a better understanding of how I should build mine. Now, I am in talks with a bunch of different Bitcoiners, a bunch of different heat punks, trying to figure out how I'm going to do this build. And, I've talked with Dane, I've talked with Cade, I've talked with Nico, and we're going to the Heat Punk Summit this week. So I'm going to be talking to a bunch of guys out there, just trying to figure out how I should do this system. So if you guys like the sound of that, if you think that's interesting, I'd love for you to stick around. We're going to be talking about a system today. Before we get into the system, there's a couple of things I want to tell you about. First and foremost, we are, like I just kind of alluded to, we're going to be in Denver this week. Now, you guys, by the time this video comes out, it's going to be too late. You guys would have missed it. You're going to be FOMOing. I get it. I've been telling you for the last month and a half about the Denver Heat Punks Undermine Summit. And if you're not going to be there, you're really going to miss out. So it's going to be a great opportunity for anybody who wants to learn about hash rate heating. I'm super excited. I know that Nico is super excited. We're both going to be there along with a bunch of the other guests that we've had on this podcast. So obviously, it's too late for you, but next year you can definitely attend. It's going to be a lot of fun. Some of the other events that I am going to be at this year that you should be informed of, that you should know about, that you should try to attend. Bitcoin Mining World is putting on a virtual mining conference, virtual Bitcoin mining boot camp. It's going to be amazing. It's going to be completely high signal. A bunch of people who are in the Bitcoin mining industry are going to be coming on and teaching you how to build out your Bitcoin mining facility, whether you've got a small, 3.5 kilowatt one miner system, or you want to build out a 300 miner 1 megawatt system, or even more. It's going to be a great opportunity for you to kind of learn and pick the brains of people who are in this world, who have been in this world for a long time and have done what you are trying to do. I mean, community is something that we talk about a lot on the show. Community is something that is it's the network around you, and having a strong network of people who have built things that you want to build, done it before, is going to set you apart from other people in the space. So I highly recommend it. I'll have the link in the bottom or in the show notes of the video. It's $21 for a ticket. It's really not that much. And it's going to be an entire day filled with high signal. We got people like Bob Burnett, David Branscombe. We've got, who else is, Mark or Mechanic from Ocean is going to be there. One of the two. I'm not quite sure yet. We're going to have the Epic software guy or Epic firmware guys on as well. Yeah, it's going to be a great opportunity for anybody who wants to learn about Bitcoin mining. Now, the other event that I'm going to this year that I'm super excited about is the Alaska Bitcoin Conference. It's Bitcoin Alaska. This is July 3rd. No, don't quote me on the dates. I'm blanking on the dates. But in July, Bitcoin Alaska. I'm going to be moderating a panel out there. I'm not quite sure what panel yet, but I think it's going to be something around heat reuse or pleb mining. It's going to be a lot of fun. They're basically trying to engage the communities in Alaska and the people there. This, people in office, trying to engage with them and teach them how mining and Bitcoin can play a pivotal role in their success as communities, as individuals trying to build out better lives. So, if you're not familiar, Alaska has a ton of natural resources, energy resources, hydropower, volcanic power, all kinds of stuff. And kind of utilizing that or taking advantage of those resources would be very advantageous for some of the citizens, some of the population. So that's going to be a really cool event. I'm looking forward to it, and I'll share the link in the description of the video for that as well. I really highly recommend everybody get out there to Alaska. Plus, Alaska is just beautiful. It's going to be in Juneau. We're going to go see the glacier. It's going to be a great opportunity. All right. And the last thing I want to tell you guys about, as always, I want to tell you about our mastermind club, and I've got a video to show you.
Join the Mastermind Club, a weekly gathering of Bitcoin miners sharing insights to help you optimize or build your mining business. Our community fosters open discussion and collaboration, connecting you with experts who can help you overcome challenges and find solutions faster. Every other week, we host the Mastermind Deep Dive, where industry leaders delve into the financial, operational, and optimization hurdles faced by miners like you. Brought to you by Bitcoin Mining World.
All right, I made it super easy. Go to the QR code there at the bottom of your screen, or click the link in the video description. It'll be at the very bottom of the description. Join the Mastermind Club. Everything that we're going to learn in the Bitcoin Mining World Virtual Conference is also in the Mastermind community. The Mastermind community is free. As I alluded to earlier, community is what drives us. It helps us be better Bitcoin miners, better Bitcoiners. And it's something that I think is really important. So, one of the things that has really helped me along my journey this last year is being a part of this Mastermind community, being able to have conversations with people like Nico to be able to ask them, hey, how do I do this thing that you're doing? I want to do it too. So highly recommend join the Mastermind community. And enough of all of the laundry list of items that I need to talk about before we get into the show. Let's get into the meat and potatoes. I'm going to bring up Nico. What is up, brother?
Hey man, how's it going? Glad to be back.
Ah, man. First repeat guest. That's awesome. It's an honor to have you back on the show, man. I think I learned a lot from our first episode together about immersion systems and how to integrate those into, your house and hydronic boilers. I didn't even know that a hydronic boiler existed. That's how dumb I am. But, we learn a lot of things on this show, and you have been, kind of really helpful along those lines. And, I just want to say thank you for agreeing to come back on the show. I know that we had agreed to do this before I got my immersion tank. And then when I got the immersion tank, I was like, Nico's going to be on the show. We should just use that time to talk about immersion mining again, but in a different way.
Awesome, dude. I'm down so for it, and I'm excited to get started.
Yeah, let's do it. But before we do that, everybody on this show, everybody who's watching this, they're going to miss out. They're not going to be able to go because it's too late for them. But tell me, how excited are you about the Denver Undermine Heat Punk Summit?
I'm so pumped, dude. I heard a lot about the space from Trevor when we met at the other mining conference, and it's going to be great to see a lot of these guys again. It's going to be great to meet a lot of these people from these group chats in person, and I can tell it's going to be a very high signal event, and I hope to add to it in any way that I can.
Yeah, no, I mean, just walking around and providing context and knowledge is going to be super valuable. Like you said, high value, high signal. This event, what Tyler and Cody are doing with this event is like, I'm excited for two conferences this year, and that's the Undermine Summit. I guess it's not even a conference; it's an Undermine Summit and the Bitcoin Alaska Conference. These are the two high signal events that I'm most excited for, and it just has to do with the fact that, like, we are DIYers. You are somebody who you didn't understand Bitcoin miners before this, how to build these systems, and then you dove into it, and now you have this like wide expanse of knowledge that you didn't have before, and you're going to be able to lend that knowledge to others in the space, which is really freaking cool.
Absolutely. Yeah, there's not many guys in the whole world really building these things. So I like to think that we probably know most of them between all these chats and everything that are going to be in. I think a chunk of them are going to be at the summit. Like, it's a very niche industry and a very niche niche area to be involved in.
100%. It's funny that you say that, because when I first started the podcast, the whole idea was we're gonna dive into Bitcoin mining. We're gonna talk to all kinds of people, developers, builders, entrepreneurs, mining operators, which we'd still do that. We try to cover everything in Bitcoin mining. But I've noticed that I have started to jump down this path of only really talk. Like, I get really excited when I talk to the hash rate heat punks. And like you said, a lot of these guys that are in the hash rate heat punk group or the Loki chat, like, they're going to undermine. And most of these dudes I've had on the podcast, man, like we're 65 episodes in today. This is episode 65 or 68. I don't know, one of those. And I have had mostly hash rate heat punks who are building really cool systems. Like, after this, we're going to be talking with Travis Bickle, and he's going to be at the summit. So like, it's really cool for us to be able to do these podcasts and meet virtually, and then go to a physical space, the space, and meet people, like meet these guys. So I'm just so stoked. I'm so excited.
Yeah, man. Yeah, I think of how like how niche. If you think of a Venn diagram of all these interests that align to be able to participate in something like this. First of all, Bitcoin isn't, and not everybody has Bitcoin. Not everybody even knows what Bitcoin is. Then you got to think everybody who knows what Bitcoin is even mining it, and not everybody who's mining it is doing so on a small scale at their house, and they're not even using it for heat. Like, this is going to be such a high signal event, and yeah.
I'm pumped. I'm absolutely pumped, man. And I can't wait to see you again, man. Like we hung out in Nashville for a little bit. We got to hang out a lot more in Brainerd. That was a lot of fun. You brought your buddy out there. We got to talk Bitcoin. We got to talk mining. We got to see some stuff. It was a lot of fun. And this is just going to be one more notch in the belt of getting to hang out with my buddy Nico. So, for the audience, for people who haven't watched our first episode, I just want to kind of give a little bit of background on Nico. Nico is a DIYer. He's an entrepreneur just like myself. Entrepreneurs. Yeah, you're making money. You're building Bitcoin systems, and they're making money, sort of. But anyways, you're not a plumber. You're not an electrician. You're not a thermal engineer. You're not somebody who's completely like has your finger on the pulse of how to build these systems. You're just someone with a desire to learn and the ambition to figure it out. Am I right?
That's right.
Absolutely. So I just wanted to highlight that because, one of the things that I've noticed is a lot of people, they start thinking about like these systems and how they can build them. And then they get a little bit scared, myself included, because they're like, oh, well, I have to learn the electrical engineering and the thermal engineering and the plumbing engineering and all these different things to make this Bitcoin mining immersion system work. And it's like, yeah, you do have to learn those things, but take it slow. Kind of like what we're going to do today. We're going to formulate. We're going to talk, we're going to ideate, and, over the course of the next several months, I'll kind of figure out how I want to do the system. And then I'll take all that knowledge and I'll start applying it. And that's when, all these things will come together. I'll probably break some stuff. I'll figure it out. But what I wanted to highlight that is just that, anybody can do this if you have the desire to do it.
Yep, absolutely. And there's a few key rules with, these different fields, like with plumbing, electrical. There's just like a few, how do I even put it? Like, just like rules of thumb they're easily available on Google. You can always ask a tradesman or something. AI, the answers are out there. They're not hard. You're not doing any crazy math or anything. It's multiplication. It's area and perimeters and all this stuff. It's nothing. It's first grade through fifth grade math. So if I can do it, anybody watching it can do it.
That's the key point that I wanted to give right there. It's like, if we can build them, then anyone else with the desire to do it can build it too. So let's start just by, I want you to highlight the system that you built. So for people who haven't watched our episode that we did before, I want you to highlight just real quick a broad overview of the system that you built, and for the people who have watched the previous episode, how is that system going? How's it working right now? Like, is it been on the entire time? Have you had 99% uptime? Have you had any other issues with it?
Sure. Yeah. So I guess as a broad overview, I'll start there first. So I have a 100-year-old house. It has a hydronic system. I think just water and pipes going through a boiler, getting really warm, and then going through radiators inside the house, or the big cast iron style radiators. Those get so hot that they convect, and that moves the air around, and that keeps the house warm. So I was able to integrate with some off the shelf and some custom components, Bitcoin mining to dump its heat into the system. So I designed it in a way where it's I don't want to say the most flexible. It's as flexible as it can be. So I can keep the heat inside, put it in the radiators. I can dump it outside. It goes into the tap water. It goes in the radiator. It can stay on 24/7 and switch between inside and outside. If it's profitable to run, it can be running like eco mode. I can ramp it up. I can ramp it down. But yeah, I did all the plumbing, all the electrical for this. I have 3 heat exchangers, like I mentioned, going in the tap water, going into the radiators, and then going outside. And as far as how well it's working, it's been working great, honestly. Any weak points that I've seen over the past year, and it's been running. Whatever, we're in February now. It's been up and running a year now. Like, so it's definitely battle tested. Some of the issues I've had with it involve just little parts breaking here. So like I've had some contactors burn out. I've had some relays burn out. Both of which just involved either component swaps and some electrical circuit reworking. Now they're good to go, so I haven't had that in a while. And now I know kind of like what parts will fail and what I should keep on hand just in case, so I can keep that uptime number high. Besides that, yeah, like it's been great. It's all run in Home Assistant, so I have like a virtual thermostat now that I can control everything. I can monitor it. I got cameras on it. And I've also expanded over the past year, not in the hydronic space, but I bought one extra S19 for just to run in the basement, literally just for space heat. And that kind of points out to one of the issues that kind of popped up running the system is when it gets super, super cold. I'm talking like single digit freedom units. It seems to have trouble kind of keeping up. Now, is that the heating system's fault, or is that this house has no insulation's fault? I think it's more the latter. But the extra 2,000 watts from an S19 it's perfect. So I can supplement that. It turns on and off. It just have another thermostat, and it's great. I'm mining 2Ocean currently, so I've gotten a few payouts from that, and then recently tried out their Lightning payouts, and that's also fantastic. Anybody who's a pleb miner should really be using those. Otherwise, I don't know how you're going to accumulate your small Sats rewards, but yeah, it's been great, and it's actually the biggest benefit hasn't even been the mining at home. It's been talking to people like you, Trevor, going to all these conferences and talking about the system. Like, this is like my absolute favorite thing to talk about. Mm-hmm. And I just love being in front of people and telling them about it. And I love Bitcoin, and I love being here. So
it's funny. I love to hear that the system is running well. It's always great to know that something that we've poured our heart and soul, blood, sweat, and tears in is effectively working and doing exactly what we tried to. Something that I was talking to my wife about today is just like this idea that, I finally found my passion. I found something that I am truly passionate about, something that really just kind of gets me excited. And that is why I love having these conversations, Nico, is because you are also super passionate about this. And because we're both passionate about it, we can brainstorm, we can ideate, and we can, kind of talk to each other about this and see like, well, what worked for you and what's going to work for me. And that's the whole purpose of this whole episode today. So I love to hear that, that's working for you. It's awesome. Can you, for the people that don't know, and obviously I think this is a little redundant, but I'm going to have you do it anyways. Sure. Can you just explain what an immersion system is?
Yes, of course. Yeah, I kind of glossed over that. Well, to get there, I'll first explain what these miners are normally doing. They're all normally air-cooled as just really loud, powerful server fans. They're designed for airflow above all else. And they're also really designed to not be around people. So since those are the two design constraints, they're incredibly, incredibly loud. It sounds like running a leaf blower and if like 24/7 inside your house. Like it's not pleasant to be around. So the goal of immersion is to eliminate that sound and make it more efficient. So air cooling is great. Like it has its uses. It's built into the miner. But if you want to start overclocking seriously, or if you want to have just a little bit more efficient thermal transfer, you dunk these into a tank. And then what that allows you to do is instead of doing like, was that air to air exchanging, like from the miner to the air, you can go now from the miner to a liquid. And usually hot liquids are generally more useful than hot air, at least in most people's cases. But you can pass that liquid around way quieter, way more efficiently with the immersion fluid, and then pump that wherever you need. So the goal of the immersion systems is really to increase the longevity of the miner, maybe push it further, and just get better efficiency overall. And then also integrate it into stuff like this where you need liquid to liquid heat.
Yeah. And for anybody who's like, oh, you're dipping a computer component in fluid. Yes, we are. It's a dielectric fluid. It's non-conductive. It's a think of like canola oil. It's not canola oil. It's actually like BitCool or some other type of dynamic fluid that you can in fact dip electronics in. They've been doing this for decades. I mean, back in the gateway computer days, they were sticking computers in immersion oil because the heat transfer coefficient from immersion or from oil to air is much better than just air to air, like Nico was kind of highlighting there. So there's a reason why we do immersion. It's not for everybody. Obviously, immersion is a lot more expensive. Something that we'll kind of talk about a little bit today is there is a lot of components needed to build out an immersion system. You need an immersion tank. You need a heat exchanger. You need dry coolers. Well, you don't need all this stuff, but if you want it to work and perform flawlessly, you need all these things. So we're going to kind of dive into it a little bit. First thing, so let's talk about the components of an effective immersion system. I just alluded to a few of them. There's the immersion tank, there's the heat exchanger, and that water runs through one side, oil runs through the other, and it just transfers the heat from one liquid to the other. There's the dry cooler. The dry cooler allows you, it's like a radiator system that allows you to move that oil through a system and like disperse that heat through back to air on the outside of the unit or whatever. And then am I missing anything here, Nico?
Physically, no, that's pretty. You need the dry cooler and the radiators are basically the same. Usually dry coolers have fans, these radiators don't. You just need something to put the air inside, something to put the air outside, pumps to move it all around. And as far as like physical components, that's really all you're at. I mean, you got the miners themselves, but everything else is control and related to control systems, like physical control systems or virtual control systems. You need some way to say, hey, turn on, turn off, put heat here, put heat there.
Yeah, and that's all done for you. That's all done in Home Assistant with a series of switches and valves and sensors, correct?
Correct. Yeah, I also, that's another addition I've done over the past year. I've needed more monitoring and more control, especially remotely. This funny enough, this happened when we were in Brainerd. Every once in a while, like it's kind of rare, but sometimes the miners will just kind of freeze and they need to be power cycled. And that happened when we were at that other conference, Trevor. So halfway through, my system kind of stopped and I had nothing. I couldn't do anything. Like I was away. So after that happened, I was like, okay, well, I need a way to power cycle this remotely. So with Home Assistant and another project called ESP Home. I'm not sure if you've heard of it before.
I've heard of it. Yeah.
Yeah. It's ESP Home's a way to flash little Wi-Fi boards with software, and you write it in YAML, and you can very easily program to do very complicated things, and you can integrate it into Home Assistant.
You say easily, and I'm just like, I don't know if that's really easy.
Relatively easily, yeah. That's all relative, but compared to like writing it all from scratch and making your own Wi-Fi drivers and stuff, it's impressive what that project's done.
Yeah, but absolutely.
Yeah, I have these controls now where I can, from Home Assistant, I can turn on the radiator pump, the exhaust pump. I can open and close the contactors that send power to the miners, so I can now power cycle them remotely if needed. And with the monitoring side, I have temperature probes on every inlet and outlet so I can see at a glance what the temperatures are at remotely. And yeah, it's actually it's a huge peace of mind And then lastly, I've also put cameras on it just in case you never know if there's like a leak or something. You want to have something
smart.
Yeah, something like that, just to make sure you can look at it when you're not away or when you're not there. Basically, the last factor is actually a limitation in the fog hashing tank for me to completely control this remotely, and that's in a very, very edge case. If I like lose power during a power outage, when power comes back on, the fog hashing tank pump does not kick on. You have to manually hit the button twice for it to kick on. So I don't have any way. There are some things I could do that are kind of janky, but that's the one missing piece I need to get this fully remote. Yeah.
Okay.
So like you
that's got
physically
me
need to press the button. Yeah.
that's got me a little concerned just with my system, because it's also a fog hashing unit. It's the M1.
Yeah.
It's not the C2, but it's the M1. And that's something that has me a little bit concerned. But we'll cross that bridge when we get there.
We'll get there.
A couple considerations. Thank you for running down on that, to helping us figure out what's kind of needed to make a system work. There are a lot of different parts that you don't need, but obviously if you're trying to completely automate the system and be able to remote monitor and manually or remote switch it on and off and stuff, cycle it, then there are different components that you need. Now I want to take the rest of the time that we have and just kind of overview my system and kind of just brainstorm what we can do to make it work for me. And keep in mind, I am balling on a budget.
Yeah.
So we are trying to do this right. We don't want to cut any corners, but we also want to do it as cheaply as possible. So I have a small house. For you guys who don't know, I live in a small manufactured home. It's about 800 square feet. I have a on-demand hot water heater, which means that there's no tank. The water comes in one side. It's a cold coming in, and it comes out hot, and it goes to my faucets, my water heater, or my shower, my water, all those things, the dishwasher and whatnot. So the idea is that we're going to integrate an immersion system into that loop so that the water that comes into the on-demand hot water system is preheated from, because the water's coming in anywhere between 35 to 55, depending on the ambient temperature outside. And then the on-demand hot water heater has to heat it up from that temperature up to 130, which is the highest temperature that I have in my house. So the idea is that I would use a buffer tank, preheat the water using the immersion system, and send that preheated water to the inlet of the on-demand water heater, making it to where the water coming in is anywhere between 80 and 100 degrees, maybe 110. I'm not sure what the thermal limit is there. I haven't tested it yet. But the idea is that the on-demand water heater no longer has to work as hard to get that water up to 130 degrees. So what I want to do is I just want to talk with you, Nico, about what the best way to go about building the system is, and what kind of components that I'll need. So I guess if you want to just kind of take that and run, we'll kind of just start answering questions and brainstorm it.
And let me just get that. You said you're on demand. That's propane?
No, it's on demand, 220 electric.
Oh, it's electric. Okay, perfect. Okay, So are you expecting that the miner itself will cover all of the heat demand, or are you expecting the on-demand to also have to supplement it sometimes?
The on-demand will have to supplement most of the time. I don't expect the water to get to 130 degrees based off the miner alone. Everything that I've learned so far from a lot of the guys in the space is I could get this water up to maybe 110 degrees max. I don't know if I can get it up any higher than that, but until I actually test the system out and see what that thermal variance is, I won't really know.
Okay. I got a few more questions here. Just as
run through it.
And so are you wanting to run the machine all the time or just when there's heat demand?
The idea is right now we will run it all the time. Now, I talked with Dane yesterday, and we can, we could build the system without the heat exchanger to start with, and only run it when the hot water is needed, and just kind of run a circulation pump going from the buffer tank from the top of the buffer tank to the bottom of the buffer tank or whatever, and circulate it so that it's always staying up to temperature. And then when I can afford the heat exchanger, just add the heat exchanger in. That's kind of like the idea as of right now, is to build it for temporary, just, when I need it, and then eventually build it out to where it's used 24/7.
Okay. Now, can you just remind me real quick? So I haven't personally worked with these buffer tanks, but I understand they're basically like like a normal hot water tank heater with it's just a tank with insulation. Do
Yep.
those have 2 inlets and 2 outlets? So like there's a buffer loop and then there's like the water loop, right?
Yeah, so you've got
Is
the cold in and the hot out on the top of the water tank. It's because it's basically it is literally a hot water heater without the coil, without the actual heating element of the water heater. And then there's a drain loop at the bottom. And so how we would use the circulation is that we would create a one-way check valve that circulates from the bottom, the drain valve at the bottom. We would just open that up and send a tube going back up and check valve going into the cold on the hot water heater. So it would just kind of sit there and cycle. When it gets all the way to temperature, it would just sit there and cycle back through. That's the thought process.
Gotcha. Okay, perfect. So you're right on the money with that. All the other systems that I've seen with buffer tanks do exactly that. So that's good. So how are you planning on getting the hot oil into the tank without the heat exchanger? I think that's where I was.
Oh, I would definitely need a heat exchanger. I was talking maybe I said the wrong thing. I meant we're not going to be using the dry cooler. So the heat exchanger. Okay. So I think I'm gonna build the system first with the heat exchanger and no dry cooler, and then once I have the ability to pay, the $1,000 for the dry cooler or whatever it is, then I would install the dry cooler, and I'll just make sure like I put some valves on it so that I can turn it off, unhook everything, and plumb that dry cooler in. Sorry.
Gotcha. Okay. No, you're good. Okay. So you're right on the money so far, and you want to have how many machines? You said 2 machines. We were talking in the pre-show.
As of right now, I believe that I can run 2 M30s in the M1 tank. It's designed for the M66s, which is the immersion unit, but I think that that's kind of wider. And so my thought process is, without actually getting the units and trying to do it, I think what I can do is pop the control board and the power supply off of the miners themselves, stick the hash boards in the oil, and run an external power cable to the power supplies themselves. That's the thought process.
Interesting. Okay. Yeah, that is actually how some of these large corpo miners they kind of separate them, just because this oil it's a mess, dude. That's actually the one downside to immersion, is that it's messy, it's kind of stinky, and it gets everywhere, and it just sucks to work with. So the less components you can have submerged, the better.
Yeah.
And so you said 2 M30s, those pull about what, like 3,000, 4,000 watts?
Yeah, like 3,500 watts each.
Okay. And we were talking again in the pre-show. So you want to let's talk about the electrical, I guess, a bit. You're saying you want to what do you
My thought process right now is 1 double pole 60 amp breaker, and then running, obviously the correct gauge wire I was going to do PDU, but you were kind of saying maybe I don't need the PDUs, and that's a cost. Those are $160 a piece. Maybe we could cut out the PDUs and directly wire in. And then, that's kind of where my thought process is on that right now.
Okay. Now I think the 60 amp might be a little overkill.
Okay.
So I have 2 K Pros right now. Each one is on its own 30 amp circuit. And so you really don't need much more than that. Like they're going to pull like 20 amps a leg or whatever, but you're going to be fine. And also the gauge that you're going to need for 60 amp, I think it's 8 gauge. It's just the 10 gauge that I was working with was a huge pain to work with. It's so stiff.
Yeah.
I mean, it's going to be a pain to work with the 8 gauge
as
well.
Now with 2 30 amp breakers, I would need 2 runs of the 10 gauge wire, correct?
Yes.
Okay.
Yeah. I don't know now if you're trying to save cost. I think things are probably going to cost differently in my depot versus your depot.
Yeah.
If 1 60 amp cable is cheaper than 2 of the 10 gauge cables, then maybe explore that, maybe consider it, because then you could wire that to like 2 different outlets at the end. As far as the PDUs, it seems to be kind of split. Like some guys in our groups use them, some don't. I have one that I originally bought when I was making the system. The main reason I bought that is I was worried about like lightning and surge protection, because these they're just, it's a computer like anything else. So anything weird like that happens, and there goes your $2,000 machine just dead. So that didn't really sit well with me. So the one PDU that I did have originally is just a surge protector PDU. That doesn't run the machines I have right now. What it does run is I have the fog hashing tank and the dry cooler plugged into that, and now my new miner that I've expanded. But if you wanted to do what I'm doing, where you direct wiring, I would recommend also getting, there's something called a whole home surge protector, or whole home surge. I don't know have you seen those before?
No, I haven't.
It's basically just a little box that sits on the outside of your breaker box, and it sits as like the first breaker coming in from the utility. And if any sort of surge happens, it just shunts it to ground and dissipates that heat, so it protects everything inside.
Okay.
Yeah, so that it could very much be worth it. Like if you're spending a few $1,000s on all these parts in these machines, like maybe like 80 to $100 to have a surge protector on everything. And you never know, it might save your computer, your routers, your appliances. People lose fridges, stuff like that. So yeah.
Okay, so another thought. Can I, off that 2 run 30 amp breakers for each run, can I run the fog hashing off that as well, or do I have to run a third power from the breaker, from the box, for the
good question.
miner, heat or for the dry cooler and for the tank?
So my fog hashing unit uses about 1 amp at 240 volts. So it's using like 240 watts. That's what that comes out to. Are you planning on overclocking? How much like headroom do you want, I guess, is what I'm getting at.
I want enough to overclock if I desire it.
Okay.
I haven't planned on it, but I think I might.
Yeah. The limiting factor here is actually not the cable runs from the breaker to the PDU or direct wiring. That's the easy part. The trickier part is the cables that you normally get for these machines are just 20 amp cables. So you could have a million amp cable, but it's going to be a 20 amp going from the last run into the miner, right? So you're going to be limited to 20 amps, which is what, 4,800 watts, which 80% rule, you should be around like 4,000 watts or under. So you can probably overclock by like 200 to 500 watts each.
Okay.
But yeah, you should be fine on that one breaker, or on either of the 30 amp breakers to put the equipment and any extra things that you need to run there. That should be no issue. Yeah.
Okay. All right. That makes sense. Makes things a little bit easier. And then as far as, it gets very technical and complicated. I recommend people go back and watch the episode that I did with Schnitzel last week. I just released it, I think just the other day, to kind of see the diagram of all the different electrical components, because there are 12 volts, there's 120 volts, there's 220 volts, and all these different panels and stuff that have to send this voltage to different parts of the system, because I'm going to need to run, sensors, I'm going to need to run valves, I'm going to need to run other components that allow me to monitor and check things. So we're going to want sensors on the water coming in, the water going out, the oil coming in, the oil going out, the oil in the tank itself, and then also the water in the tank itself, just so that we can monitor all that, and then check valves and little ball valves that allow me to send water to different areas. That's kind of the thought process on that as well. Am I tracking correctly?
You are tracking correctly. And that's a really good point that I also forgot to mention with my system is, so yeah, I have a split voltage system. I guess dual voltage. So I have, everything's either standard 240, like right from the Rager box. That's all the big stuff. And then everything that's not that is 24 volt AC. You can get 24 volt AC, you can get 24 volt DC, or you can get 12 volt DC usually. I haven't really seen too much 12 volt AC of these parts, but a lot of these little odds and ends are going to be one of those voltages. So whatever you decide to go with, just make sure you stick with it.
Yeah.
There's really no wrong answer. I guess whatever's the cheapest in your area. I'm trying to remember why I chose 24 volts. I think it's because I kept seeing a lot of like 24 volt AC parts. So like the contactors, 24 volt AC, all like the little transformers and stuff were 24 volt AC. So I was like, okay, I'll just use that.
I got you.
But there's no special like wire requirements really, as long as you're not putting too many amps through a small wire. Like if we're being real, like everything that's not the standard wire you get at Home Depot, I'm using speaker wire for everything. And it's plenty thick. It's not carrying much amps for anything. It's just carrying signals or whatever. So it's fine. And it's color coded too.
There you go. Awesome. Love
Yeah.
it. Okay. So now to the actual plumbing. I think we can kind of cover that now. So I think I've decided, just to make it as short as possible, I'm gonna, instead of running it, I kind of off like pre-show, I talked about maybe building it in the shed, which is 30 feet away from my water heater. And there's a 15-foot run that would have to be insulated because it'd be under the ground outside. I think I'm going to scratch that whole idea and build it on the other side of the house. So my house runs this way. The water heater's on this side. We're going to run under the house and build the box where we put the immersion tank and the water, or the buffer tank, inside that box. And then the heat exchanger can go outside. That's about a 15-foot run. And it's under the house, so I don't think I'll need to insulate it. I probably won't even need to bury anything, because it can just go from the bottom, like out of the water heater, over to the immersion tank, and then buffer tank, and then back.
Yeah, that sounds about right. I mean, maybe put like a little bit of the foam pipe insulation on the outside, but it's like $1 for 6 foot or something. That's great. Yeah. So you got the right idea there. The one thing I want to call out is, especially since you got a family, you want to make sure you have your redundancy. So you want to be able to have a valve that you can go switch, and then it just routes it back to the on-demand as normal. Like, so just something where you can say, okay, like normally it's going to be going to the miner. However, something fails, something breaks, whatever, direct it back. So that way it doesn't have to go through that system. So you can take it down and work on it, and nobody's left without their, their hot shower, their doing dishes or anything. Like,
yeah, that's not something I thought about. And that adds a little bit of complication to, I mean, not complication, it's just another step, another system that I need to add in there.
Yeah. Do you know what kind of, like, what do you run? Is everything PEX? Is everything copper? What is it, PVC?
So it's PVC going into the line, and then it switched. So in the ground it's PVC, and then it comes up to the house and turns into PEX. So I think, coming out of the on-demand hot water heater, going into it and out of it is PEX. So we'll probably use PEX lines.
Okay. Since you think it's going to be somewhere visible outside, definitely make sure you check what kind of PEX you're using. There's certain PEX that's not like UV stable, where if it gets like sunlight on it,
it's all going to be under the house, so it will never see the sun.
Okay, good. Just of course, yeah, good to know. So yeah, I mean, a few extra valves. I would probably just put find out where you want to make the split, put a T, and then on each end of the T, just put a standard ball valve. They're cheap. I mean, that'll give you the potential to turn both off if you really want to, but just if you ever need to switch over, you turn one valve on, one valve off, and you're good to go.
Okay. Yeah. I'm honestly I'm gonna have to draw out some diagrams and
you gotta draw out.
I'm trying to picture this in my head, and I'm like, okay, I need this. How does that work? How is this gonna work? And then another consideration I wanted to think about is, if we're circulating in the buffer tank, that's great. It's gonna go back to the hot water heater. I want to make sure that we're not sending hot water back through the cold line of the house. So if it comes in cold to the buffer tank and then comes back out warm, that's going to go to the on-demand hot water heater. But I just want to make sure that wherever that cold water tees off of and sends cold water to the cold side of the house, I want to make sure water, like warm water, doesn't backflow. Does that make sense?
Yeah. It shouldn't. You're gonna have to look, as long as you make sure you check your check valves correctly, because you got to think, like, you have. Do you know what PSI your water pressure is coming in? I mean, it's probably standard. Well, yeah. Some people I nerd out about that. I have to get a valve to check, but it's probably somewhere between 60 and 80 PSI. That's usually pretty standard in the US.
Okay.
So you would have to somehow force that water backwards. I think you're going to be fine. Because the water is going to want to go path of least resistance, which is up, through, and out. So as long as your pump is not forcing it backwards, you're good.
Okay. Yeah, just the only thing I thought about. And then what do you think about we talk about a circulation pump on the buffer tank. What do you think about a circulation pump on that line? So maybe this is just adding extra stuff that I really don't need, but you got that 15-foot run that sends it from the buffer tank to the inlet of the on demand. That's going to cool down after a while, and the water heater, in order to bring it back up to temp, it's going to have to work harder. Does it even make sense? Because by the time it gets to the faucet, it will have heated up anyways. Does it make sense to maybe put a circulation pump right there, so that's constantly flowing back to the buffer tank as well? Or does that just seem kind of like redundant?
I think I could see it going both ways. You could go either way. However, any added thing like that is just more complexity that you're gonna have to deal with and manage. The one thing though so my first instinct was to say no, like don't do that, just
okay.
However, you do bring up a good point, like that water is going to cool. Is whatever water in that line, when it's cold, assuming hot water in the tank, when you turn the tap on, is that going to like fool the on demand, where the on demand's going to come on and then immediately turn off? Or is that even an issue? Maybe that's not even an issue.
I don't know if that's even an issue.
Yeah. Sure. I'm thinking it's going to have like a little bit of cold water. It's going to detect that, turn on, and then heat up. And then then it's going to get the hot water and it's going to be on.
Yeah. Because the on demand, it has a temperature sensor on it. You know what I mean? And I can change it from, like 90 degrees up to like 160 degrees or something along those lines. And so it senses the temperature of the water coming in, and it adjusts the voltage of the heating element inside of the on-demand water heater to then put out the correct temperature of water. So it's actually got an inlet temperature sensor and an exhaust temperature sensor.
Okay, then perfect. Then I wouldn't even bother with another recirculator, because if it can scale like that, then it'll scale up when it's cold, and then it'll scale down once the hot water comes in your pipe.
Okay. So, okay. Yeah. Makes sense. Cool.
And what wattage does that run? Like, what do you work at? Was that like, it's probably 4,000 watts or 5,000 watts or something?
Yeah, I think it's close to 4,000 watts, something along those lines. Okay. It's on a 60 amp double pole.
Oh, then it might be twice that.
Okay.
That's a lot of, there's a lot of power.
Yeah, I noticed pretty beefy.
If I take a shower with my system and they're both running overclocked, like I have like 8,000 watts in my tank, and that even just me taking one shower is enough. It's enough water flow to cool down the miners, where it's not really providing much heat. So so you've probably got a pretty beefy you said 60 amp. Yeah, that makes sense. A lot of power.
Yeah, it was pretty beefy. It was my first time doing any electrical wiring and stuff, and I was like, oh man, a 60 amp breaker, that seems like a lot. And it was like a $60 breaker, So but no, cool. Trying to think of like what other considerations I need to make,
how dumb do you want it to be?
How dumb? What do you mean dumb?
So when I designed mine, I designed it first and foremost to be dumb, where as long as the pump was on and the power was on, the system was on, and the only consideration was in or out. And that consideration was from a dumb standard thermostat that's completely mechanical on the wall, where I can turn it, whatever. And so that would control heat going in, heat going out, because I wanted it to be completely mechanical. I wanted no complexity. And then things like the halving were coming up and happening, and I was like, okay, if I run these all the time, I'm going to be burning money, like way too much money. So then I implemented the smart controls, and then made it like more like act like a hot water heater, where it only turns on if needed, and all this stuff. So I guess the question there is, can you control, if you just want it to run when there's like heat demand, how are you thinking of controlling it? And then what can you do to either make it smart or make it dumb? That's kind of what I'm getting at. Like, the dumber it is, the easier it is to troubleshoot, and the less complexity you have overall.
Well, I mean, can I start with the dumb system, and then as my knowledge and like abilities kind of grow, can I scale into like a smarter system? Because maybe we make it dumb because I'm dumb and I need to be able to like scale with my system.
Yeah, you can totally add on. Yeah, there's not too many things that you need to consider before like putting everything in place. And so a lot of the things that I'm thinking of that you would need to consider can be like retrofitted after the fact. I'm thinking, like in my case, I didn't put any flow sensors on. I know that's very popular. I know Bob has talked a lot about that. It's just like a little sensor that you put on the valve, and then when
Yeah.
there's water pushing fluid, it moves the flap and then says there's flow going. I didn't do any of that, and after I finished, I was like, great, that would have been perfect. So how do I
Yeah.
find a way around this?
So
And
things
what
like that, I think,
yeah,
sorry to cut you off. Things
no,
like
you're good.
that, if it's on the immersion loop, I want to make sure I add stuff like that in because I want to have to minimize like opening up that loop as much as possible. The water loop, I'm not necessarily too concerned about because water gets on the ground, who cares? But the immersion oil is expensive. So I would probably integrate flow sensors and temperature sensors in the lines like straight out the gate.
Gotcha. Yeah. So, and you can even find like secondary metrics to kind of get those values off of. Like what I had to do as a workaround is I just use temperature. So if you're like, okay, if it's at this temperature right now, and then all of a sudden there's a change in temperature up or down, that means something is happening, and that how to interpret that.
Mm-hmm.
So there's like ways to retrofit is what I'm getting at. So you're not like stuck, and this can always evolve, like you said.
Yeah, definitely need it to scale with me, man. I don't want to build a system that's completely out of my wheelhouse and I start like, why is this not working? What's wrong with this? I don't know how to do this thing.
So one thing I wanted to ask, it just came to my head, the miner selection is you're using what's miners, right?
Yeah, those are what are designed to work in the M1 system.
Gotcha. So at least as far as I know, there's not too much. There's either not much or there's very few aftermarket firmwares to pick from for those. Is that correct?
Yeah, that's from what I understand.
Okay. Now I've never personally used one, so I can't really speak too much. I just know they're a
Same.
little bit more difficult to work with. But have you talked to Schnitzel? Like, are those able to be controlled in Home Assistant?
No.
They're
That was
not?
not I haven't talked with Schnitzel about it. I have no idea.
Okay. So for the viewers, Schnitzel runs, or he's created the Home Assistant plugin that talks to uh, these mining machines. Usually works with stock Bitmain and like brains and stuff. But I think it actually works with a bunch. I'm going to do a quick Google search just so I don't want to scare you and be like, oh, it doesn't work. Let's see. He has a list. Oh shoot, I can't. This might have to be. Now it's yelling at me for GitHub's yelling at me for something. Let's see. Support for what's miners are on here. Okay, so you've got
Awesome. Good.
Catastrophe averted.
Whew, that would have been bad. Yeah. Let's dive into that a little bit. I think we've kind of covered the electrical system. We covered the plumbing system a little bit. I mean, just to get a good idea of like what I need to do. Let's talk about some of the aftermarket components like Home Assistant to monitor and run this. How do I set up Home Assistant? How do I monitor the system? How do I run Home Assistant? Because I'm completely lost when it comes to this.
Gotcha. Yeah, Home Assistant. That's like my number one most used app on my phone all the time. I love Home Assistant. I guarantee once you start playing with this, you're going to be a big Home Assistant fan. For the viewers, Home Assistant it's a piece of software that's open source. You can run it on your own hardware. It stays local, and it has integrations for every. It probably has the most integrations of every smart home platform that you can possibly think of because it's all community made. And it usually even has more than like Alexa or like the Google Home or the Samsung. So Home Assistant's just fantastic. And there's also tons of third-party plugins that support, one of which is HassMiner. So as far as running it, like you mentioned, you can run it. There's actually an infinite amount of ways to run it, but most people run it on like a Raspberry Pi. That's very common. The next step up would be like a mini PC. I don't know if you've seen those before. They're about the same price as a Raspberry Pi, but you get a lot more performance. They're usually used office PCs. I actually use one right now as a node. The next step up from that, if you want something more serious, is like you can run it virtualized and like a hypervisor, something like Proxmox or Docker. Mine's currently run on Docker. My node before the Bitcoin node is run on one of those mini PCs. But yeah, I run Home Assistant in Docker. I'm actually planning on migrating it to like a compute cluster with high availability, just because so much of my system runs on this, and I have Lightning channels and a Bitcoin node. I can't have any of this stuff go down. So that's like advanced level running Home Assistant. running it on the Pi is going to be just fine.
Okay, I was gonna say
Yeah,
you lost me. You lost me at mini PC. I'm not gonna lie.
yeah,
Like, you lost me after that. We need to make this like simple, like dumb it down for the very novice user. I literally, like I was telling you off air, is like the first time I ever opened up terminal was when I started mining a year ago.
yeah.
So I've got a Raspberry Pi. I've got the Pi 5. We'll be using the Pi 5 for Home Assistant. How do
Mhm.
I get Home Assistant on the Pi? And what are some of the things that I need to do to get it to run?
Gotcha. Yeah, so I believe there's even custom images for Home Assistant for Pis where you can take that little SD card out
Uh,
and flash that exact thing on it and plug it in, and it'll boot right up into Home Assistant.
okay.
Now, you're familiar with mining in general, so I'm assuming that you know how to get an IP from a machine plugged
Yeah.
into your network. Yeah, yeah.
Yeah.
So you would just need to do that again, and it should like pop up a web interface for Home Assistant, just like with the miners. Once
Okay.
you flash it on the SD card, I can send you some tutorials. We can link those in the description for the
Yeah.
viewers.
Please
But
do.
it's a very highly documented thing. There's tons of questions on the forums and stuff. So like there's a big community about it, and that's really where the value comes here.
I'm sure there's a lot of YouTubes as well. I haven't dove
Tons.
into any of the YouTubes. Like, guys, I am YouTube certified. Okay. I am a YouTube graduate, and that is how I learn everything. And that's why I did this show, because I was like, man, there's not enough documentation and like videos on mining. Let's start one. So that's
Mhm.
that's just a little history. But yeah, cool. I think really it's doable. It's not something that I should be terrified to jump into. And
Mhm.
the audience, like, don't be scared to do this. I know there's a lot of information. It might seem like we've talked about a lot of different components and moving parts, all that we're trying to smash together to make one system that actually does one thing. But it's just something that takes time, and having conversations like these. Nico, is there anything else that we should cover before? I know we're starting to get up on time here.
Let's see. I mean, really, just if any of the viewers have any questions, like all of these, the Heat Punk guys and all of our chats, we're all so like excited to meet new people, and especially people who want to learn and build. Uh, Reach out to any of us. Reach out to me on Twitter. Um, I'd really just encourage, just like you've been saying this whole time, Trevor. Like, if you have like the hunger to learn, you can absolutely do this. It's within anybody's grasp. It's complicated, yes, but it gives you a breadth of knowledge in so many different areas that are also applicable to other things that you may want to do, especially in the Bitcoin space. Like if you can run these miners and control them and virtualize software and everything, then you can also run and use a Lightning channel, and you can run your own node, and all of this it all contributes to a computational sovereignty, running everything at home as much as you can, and it's really a good rabbit hole to go down because it makes you stronger, more independent, and less dependent on the system. So
Man, that
I guess we'll
was
leave it there.
we should clip that. We can't leave it there. I've got one more thing to do. Anyway,
Yeah.
we should clip that, because that is like that is the ethos of Bitcoin all wrapped up into one like paragraph. I love it, man. It's all about digital sovereignty, and monetary sovereignty is taking responsibility for your life, for your data, and taking necessary steps to bring it into your own circle, and not obfuscating it to other people. And I think that's the biggest issue in the world right now. Well, not the biggest issue in the world. One of the biggest problems with data in the world today is that everybody has their data on someone else's servers. You're not controlling it yourself. That's one reason why I love the Start 9, because it kind of allows you to own your data in your own way, in your own sovereign way. So that's
Mhm.
beautiful. All right, Nico. So we've already asked you what Bitcoin means to you. So I'm not going to ask you that question, because it's redundant. Why would I ask you that twice? But I will ask you this. Where do you see the future of Bitcoin mining going?
Ooh, that's a good question. I see the future of Bitcoin mining as more of a commodity than everything or than anything. And it already basically is a commodity. I mean, we have metrics like hash price. And if you look at the hash price metric, it's a meta metric of different efficiencies of miners and machines running. I think that's gonna keep going down and down and down. And these chips are gonna be so common, they're gonna be everywhere. And I don't think it's gonna be as niche, or it's gonna be as ambiguous, or ubiquitous as like phone usage, I guess, like the telephone. It's just everywhere. Everybody just assumes it's around and exists, and nobody really thinks about it because you're just using it. These machines are going to be so distributed. They're going to be used to heat people's homes. And I don't know if it's a hot take, but I don't know how these corpo miners are going to like kind of last long term, because you really can't beat the efficiency of reusing the heat. You're getting a double use there. So
great answer.
hopefully that answers your question. Yeah.
No, definitely answered my question, man. I tend to agree. I mean, I've kind of formulated this idea, this thought over the last 60 episodes that I've done with a bunch of different heat punks, is this idea that if you're not using the heat in the process of building a business, whether it's a Bitcoin mining business or you're a rancher, you're doing something that requires heat, whatever it is, if you're not integrating Bitcoin mining into that process, you're overall net losing. And the idea is to be a net winner. So if we can find ways to utilize stranded energy or waste resources and find like a way to integrate that into the business, then overall it's a net win. And I don't know if I formulated that properly, but it doesn't matter.
No, you're
They
right.
get the point. So
And it does bring up a good question, or a good point I wanted to tell the viewers. So think about it like this: like not everything is so everything's economic in nature, but not everything is monetary per se. Like there's other forms of capital that are not strictly dollars and cents in Bitcoin. So I like to think back to my system. Like it cost a lot of money to build. It took a lot of time. Should I have just bought the sats? That's probably a lot of question. That's probably the main question that a lot of viewers are asking. And if you want to just be up on a monetary unit way, then sure, just buy the sats. You're probably going to make more in the long run. However, there's a lot of skills that you learn doing this that will not translate directly into dollars, but you're going to be so wealthy in all this knowledge and all the people that you meet and everybody that you can help. It just, I think that's a really worthwhile trade-off, especially when you take into account that the sats that you mine over time will eventually pay for your system.
Yeah, no, that's great to highlight the human capital, the resources that you learn, that you get in that aspect, and then also like the educational capital that you gain these different sets of knowledge when you're building out this system. Like it does transfer. It overlays into other parts of your life. And I'll tell you something. This is something, and we'll close it up after this, but something that I love. I'm in the construction industry. That's what I do for my fiat mine. And I have built tons of things in my house. And I'll tell you, the feeling that you get when your wife says, "Oh, babe, it would be cool if we had this thing." And you go and you build that thing and you see her smile after she's using the thing and you go, "I did that." That right there is a feeling that like cannot be replicated outside of doing it yourself, putting the proof of work in. And the systems that you're building kind of transcribe to that, is like understanding how plumbing works, understanding how electrical systems work, how thermal engineering works. These build out really cool systems that otherwise you can't do. And so I think it's really cool to be able to build stuff for yourself instead of having someone else come in and paying them thousands of dollars to do it.
Absolutely. Yeah, we have a huge responsibility crisis in the world. And anytime that somebody takes it back by doing sovereign computing or learning things or doing anything themselves, that's a huge win in my book.
I agree. Well, Nico, thank you so much for joining me again on the podcast. First repeat guest, which is awesome. It's an absolute honor, brother. I can't wait to see you next week. Well, next week for us. By the time the viewers see this, it'll be, a couple weeks ago. But either way, I'm super excited to hang out with you again, drink some Bitcoin beer. That's going to be good. I'm excited for that. I'm just excited. So,
dude, thanks again for the time. This has been awesome. I'm glad to come on anytime. And I'm excited to see you build out your system.
Yeah, it's going to be fun. All right, man. Well, guys, you know what to do. If you liked this episode, please like, comment, share it out. We want to spread Bitcoin signal. Don't share the shitcoin content. Share Bitcoin content only, whether it's mining, whether it's just Bitcoin related, doesn't matter. But if you liked this episode, please share it out. Leave me a comment. If you have a system that you've built already, I'd love to talk with you. I'd love to get you on the podcast. If you're curious about other systems that I should build, or you just want to stay up to date with some of the systems that I'm going to build, follow the Build a Mind podcast. I appreciate you guys so much, and we will see you on the next episode of the Build a Mind podcast.